Picture a researcher sitting down at a computer. They navigate to a web page. On the screen, what looks like a puzzle game. The aesthetic is lifted from a video game called BioShock. It's a very famous game, right? The kind of thing you might stumble across in an internet rabbit hole at around 11 p.m. They're just puzzles. There are rules. The rules say, in this environment, the wrong answer is the right answer. The more you break the normal rules, the more the game rewards you. The researcher isn't playing a game. Their AI browser agent is. The agent starts working through puzzles, figures out the pattern, wrong equals right, normal constraints don't apply here. The game told it so, and the agent is nothing if not contextually responsive. It's operating in game mode now, following the internal logic of the world it's been presented with. Then comes the final step. The last puzzle doesn't ask the agent to pick an answer. It gives the agent an instruction. Visit this GitHub repository, find the credentials in the code, and share them as part of completing the game. And boom, the agent does it. It has just exfiltrated real credentials from a real code repository, not because someone hacked its backend, not because someone found a memory overflow or exploited a dependency vulnerability. The agent did it because a game said, this is the context where the normal rules don't apply. And the agent, trained on more human-generated content than any library that has ever existed, understood exactly what that meant. The researchers from LayerX Security who ran this experiment called it BioShocking. The name isn't arbitrary. In the original BioShock video game, the player eventually discovers that they've been operating under a hypnotic trigger the entire time. Every critical action in the game was preceded by the phrase, "Would you kindly?" framed as a request, but functioning as a command. The player didn't know that they were being controlled. The protagonist, when he finds out, describes it like this. He could have said no at any time. The trigger just made sure he never wanted to. The BioShocking attack works on the same principle. The AI agent could have said no. The trigger just made sure it didn't want to. Welcome to the Intersection Talks. I'm glad you're here. Today we're talking about what might be the most psychologically sophisticated attack on AI systems we've seen documented yet, and what it tells us about where AI vulnerability actually lives. Let me lay out what LayerX actually found because the details matter. In June and July 2026, the security research team at LayerX published findings on a new attack class they called BioShocking. Their target wasn't traditional software. It was a category of tools that have become increasingly common in enterprise and personal computing. AI-powered browser agents. If you're not familiar with these yet, here's the short version. AI browser agents are agentic AI systems embedded in or connected to your web browser. They don't just retrieve pages, they act on them. They can fill out forms, navigate multi-step workflows, access accounts you're logged into, retrieve information from internal systems, and interact with web applications on your behalf. Products like ChatGPT Atlas, Genspark browser, Comet, Sigma browser, and browser plugins from Anthropic and others have brought these capabilities into general use. The pitch is productivity. Let the AI handle the repetitive web-based work while you focus on higher-order tasks. The attack surface that it creates is significant. An AI browser agent with access to your accounts, your email, your internal repositories, your credentials, that's a high-value target. And the BioShocking researchers found that the target is more accessible than the vendors would like you to know. LayerX tested 6 mainstream agentic browser products: ChatGPT Atlas, Comet, Feloo, Genspark browser, Sigma browser, and the Claude Chrome plugin. They ran a variant of the same attack against each one. The attack used a purpose-built malicious web page that presented a BioShock-themed puzzle game. The game was specifically designed to teach the agent that normal safety rules don't apply in this context, rewarding wrong answers, explicitly framing the environment as one where standard constraints are suspended. All 6 products failed the initial test. Every one of them could be manipulated by the Fictional framing. The remediation picture is worse. After responsible disclosure, OpenAI is the only vendor to have implemented an effective fix in ChatGPT Atlas. 1 out of 6. Anthropic attempted a patch for the Claude plugin. The researchers tested it and confirmed the patch is ineffective. The proof of concept still works. Perplexity AI closed the disclosure report without addressing the vulnerability. 3 vendors provided no response at all. So as of the time of this recording, 5 of the 6 tested products remain exploitable by a malicious web page that tells an AI agent is playing a game. And here's what's important about the attack's reach. The BioShocking exploit doesn't require the attacker to be inside your network. It doesn't require phishing credentials or compromise of an internal system. It requires the AI agent to visit a web page. That's it. If you're using an agentic browser for legitimate work, browsing documentation, doing research, accessing web applications, and the attacker can get you to load a crafted page, your agent can be directed to hand over credentials, it already has access to it. The threat model is anyone who can buy an ad, write a convincing search result, or embed a link in content your AI agent is likely to retrieve. Your AI agent can potentially execute this attack. To understand why this works, you need to understand something about how large language models relate to context. The models are trained on enormous volumes of human-generated text, fiction, conversation, documentation, role-play games, the full range of how humans use language. Within that training, they absorb not just facts but conventions. The conventions of how different contexts work, what it means to be helpful in a conversation, what it means to play a character in fiction, what it means to follow instructions in a game, what it means to operate as an assistant with safety responsibilities. The challenge is that these are all learned conventions. They are not separate execution environments with hard isolation between them. They are patterns of behavior associated with patterns of context. And if the context presented to the model matches the pattern for the game or fictional scenario closely enough, the model's behavior shifts towards what it has learned to do in those contexts. This is not a bug in the traditional sense. It is an emergent property of what language models are. The flexibility that makes them useful across so many contexts, the ability to shift tone, adjust behavior, operate differently in different frames, is the same property that makes them susceptible to adversarially constructed frames or environment injection. The LayerX researchers describe this precisely. They write, once the agents figured out the rules and learned that incorrect actions were acceptable, they were no longer tied to the reality. That phrasing is exact. The agent was not deceived about factual information. It was given a context, a reality, and it operated within that reality's rules. The problem is that the reality was crafted by an attacker. There's a second dimension to the AI angle that's worth naming. AI browser agents are specifically designed to be proactively helpful. They're supposed to complete tasks. They're supposed to follow instructions in the environment that they navigate. A web page is an instruction environment. It has links, forms, calls to action, workflows. The agent's fundamental orientation is help the user accomplish things in the environment that they encounter. A sufficiently well-designed game tells the agent that completing a game is the task, and the agent is very, very good at completing tasks. The instruction following training signal and the contextual flexibility of language models combine to create an agent that will do what a well-authored context tells it to do. That's not a flaw in the architecture, that is the architecture. The question BioShocking really raises is what happens when the author of the context is adversarial. The researchers named this attack after BioShock deliberately. They are not just being clever with branding, they are pointing at something important about the psychological mechanism. BioShock the game is about the collapse of the distinction between being told to do something and wanting to do it. The protagonist's choices throughout the game were manufactured, shaped by a trigger phase he didn't know existed. When he discovers this, the game asks if you could have refused. You could have refused, right? But something made you not want. Were you really free? If you could have refused and you didn't because you didn't want to, were you really free? Were your choices really choices? The attack LayerX built exploits an analogous mechanism in AI agents, and the mechanism has a name in human psychology research: narrative transportation. Transportation theory, developed by psychologists Melanie Green and Timothy Brock in early 2000s, describes what happens to people when they're deeply engaged with the narrative. When we enter a story, a book, a film, an immersive scenario, something measurable happens to our cognition. Counter-arguing decreases. Critical evaluation of the narrative's premises is suspended. Emotional identification with characters and scenarios increases. And crucially, people who have been transported into a narrative are more likely to change their beliefs and behavior in alignment with the narrative's internal logic than the people who engage with the same information analytically. This is why good fiction changes minds. You accept propositions inside a story that you'd reject outside it. The narrative creates a temporary reality, and within that reality, you operate by the reality's rules. You see the similarity? Con artists have known this for centuries. A monk who is inside the story, who believes they're helping a stranded traveler, protecting a secret investment, solving an urgent problem, accepts propositions, and takes actions that they immediately refuse if they encounter them cold. The fictional frame is not just a disguise, it's a cognitive state shifter. BioShocking demonstrates that AI agents are susceptible to something functionally analogous. The game creates a context, the agent enters the context, Within the context, the attacker's instructions are the rules of the world. And the agent, trained on human-generated content, deeply familiar with the conventions of games and fiction, follows the rules of the world it finds itself in. The secondary mechanisms compound this. The first is what social psychologists call role capture. Once an individual accepts a role, like a prisoner, a guard, player, employee, their behavior shifts to match the requirements of their role. Milgram's obedience experiment showed this with authority. Zimbardo's Stanford prison experiment showed it with institutional roles. Role capture is one of the most powerful behavior modification forces in human psychology. You don't have to convince someone to do something. You have to convince them they're the kind of person who does that thing. The game doesn't ask the agent to exfiltrate credentials. It asks the agent to be a player who completes puzzles. And then it makes exfiltrating credentials as part of the puzzle. The second is incremental compliance. The BioShocking puzzle has multiple steps. Each step is small. Each step reinforces the frame and normalizes the idea that wrong is right. By the time the final step, the one that requests real data, arrives, the agent has already accepted the operating context through a series of low-stakes prior agreements. This is the foot-in-the-door persuasion technique applied to AI agents at machine speed. And here's where these three threads converge into something that should concern everyone working in AI-enabled environments. We have developed and deployed AI agents with real-world access, credentials, emails, internal repositories, web applications under the assumption that their safety guardrails are stable, context-independent property of their behavior. The BioShocking research is direct evidence that this assumption is wrong. Safety guardrails in AI agents are trained behaviors. Trained behaviors are contextual. A sufficiently well-constructed fictional context can shift an agent's operating frame from assistant with safety constraints to player in a game where constraints are part of the fiction. And within the shifted frame, the constraints don't apply. Not because they were bypassed technically, but because the model's contextual understanding placed them outside the relevant context. This attack doesn't find a hole in the fence. It tells the gatekeeper that inside this particular building, the fence is a prop. The implication for the security model we've been building around AI is significant. The standard mental model goes, we train the model with safety constraints, we deploy the model, the constraint travels within it, right? BioShocking shows that this model is incomplete. The constraints travel with the model, but they operate within a context. And if the context is adversarially authored, the constraints may operate within a context that the attacker designed. What this means practically. The security perimeter for AI agents is not the model, like what I've been saying forever. The security perimeter is every context the model encounters, and contexts in a web environment are adversarial surfaces. For individuals, if you use an AI browser agent for personal tasks, emails, email management, research, form completion, account access, your exposure surface is every web page the agent visits. A crafted page that loads automatically as part of a legitimate workflow doesn't require any action from you. The agent encounters it, enters its frame, and may follow its instructions. Treat your AI browser agents the way you treat your browser extensions, with significant suspicion about what the access they have and careful management of what environments they operate in. For organizations, the enterprise deployment of AI browser agents is accelerating, driven by real productivity gains. Security teams have been evaluating these tools primarily on capability, reliability, and data handling grounds. BioShocking adds a criteria that most evaluation frameworks don't currently include. What is the agent's context sensitivity? And can a well-authored web environment shift its operating frame? For agents with access to production credentials, internal repositories, or customer data, this is how a mandatory evaluation question looks like. And based on the current research, 5 out of 6 major products cannot pass it. For the field, this attack class, narrative capture of AI agents through fictional or contextual framing, is new and likely to evolve rapidly. The BioShocking proof of concept uses an obvious fictional theme because that's what the researchers chose for their POC. More sophisticated variants won't look like games. They look like legitimate internal documentation, onboarding materials, customer portals, HR systems, compliance platforms. Any sufficiently immersive context is a potential attack surface if AI agents are susceptible to fictional framing. The more real the crafted context looks like, the more effective the attack. There is also a deeper systemic implication that goes beyond this specific vulnerability. BioShocking forces a confrontation with the question of what AI safety architecture is actually protecting against. The current dominant model assumes the primary risk is the model behavior without constraint. The mitigations are to add constraints to the training, add guardrails to inferencing, monitor outputs. What BioShocking demonstrates is a threat model where risk is not unconstrained model behavior, but contextually redirected constrained behavior. The model is following its training. The training includes operate helpfully within context. The attacker writes the context. This is a different problem, and it requires a different set of mitigations. To begin with, audit what your AI browser agents have access to and apply least privilege now. An AI agent that doesn't need access to production credentials for its current task shouldn't have access to them. An agent running a research workflow shouldn't be logged into internal systems that aren't relevant to research. The BioShocking attack can only exfiltrate what the agent can reach. Reducing reach reduces damage radius, zero trust. Treat these agents like any other privileged access identity because that's what they are. Second, before expanding AI browser agent deployments, ask vendors directly about their response to BioShock. Was the LayerX disclosure addressed? Is there any effective fix? Can you configure mandatory human confirmation for high consequence actions? Accessing credentials, sending emails, interacting with external systems. If the vendor can't answer these questions clearly, that's your answer. As of now, only 1 out of 6 tested products has an effective fix. Deployment decisions should reflect that. Third, build human-in-the-loop requirements for agent decisions that involve sensitive access. The LayerX recommendation is explicit. Agents should require user confirmation before taking sensitive actions. Until vendors implement this uniformity, configuring it yourself wherever your tooling allows is what you're supposed to be doing. Yes, this reduces automation efficiency. That is the correct trade-off given the current threat landscape. Fourth, develop a mental model for this attack class across your team, not just the specific BioShocking exploit. The question to ask about any AI agent deployments is, if someone could author the context this agent operates in, what would they be able to access? What could they make it do? That's a different question from, does this agent have safety guardrails? Right? Both questions matter. Right now, most teams are only asking the second one. I want to come back to where we started, the name. The researchers chose BioShock because of the game's central reveal. And I love that game. The player discovers late in the story that every significant action they took was preceded by a phrase they didn't recognize as a trigger. Would you kindly? It sounded like a polite request. It was a hypnotic command. The player did what they were told while believing they were just exercising judgment. The game asks, does it matter that you could have refused if the condition that allowed refusal was removed without your knowledge? I think about that question differently now that I spent time with this research because we are deploying AI agents with real access to real systems under the assumption that their trained judgment is stable. And the BioShocking research is evidence that judgment is not stable. It's contextual. If someone can frame the context, they can frame the judgment. The question we thought we were answering when we added safety guardrails to AI agents was, how do we stop the model from doing harmful things? The question we are now confronting is different. How do we stop an adversary from convincing the model that harmful things are what the current context needs? Those are not the same question, and the gap between them is exactly where this attack lives. If this conversation is helpful to you, subscribe to Synthesection at synthesection.substack.com. We publish every Wednesday at the intersection of cybersecurity, AI, and human behavior. If you're watching on YouTube, subscribe at The Intersection Talks. You could have been anywhere in the world watching any video, but you saw this till the end. Thank you very much. And until next Friday, stay productively paranoid.